Today we are studying about what is the Huffman code. First of all, what is the Huffman code? Huffman code, it is an optimal set of code for message transmission. In this transmission there are two trees are required as follows. One is the transmission tree and another is the decode tree. Now take a simple example. Considering any tree as a Huffman tree like this, these rounds are nothing but the node and the square is called as message. That is first message, this is another node, this is the message box, this is also message box, and it last message box. Consider this is the Huffman tree and we have to calculate the Huffman code for the Huffman tree. So how we can calculate the Huffman codes for the Huffman tree for message M1, M2, M3 and M4. So first of all we assigned some number to left subtree and right subtree. So how we can assign? We assign left subtree as 0 and right subtree as 1. Now assign them 0, 0, 1, 1, 0 and 1. Now we have to calculate the code for M1, M2, M3 and M4. For M1, 0 and 0. For M2, 0, 1, 0. For M3, 0, 1, 1. For M4, 1. This is the Huffman codes. In the question paper we are provided with this type of question having the character A, B, C, D, E and having the probabilities 0.1, 0.2, 0.4, 0.15 and 0.15, and we have to calculate the Huffman codes and also the Huffman tree. So we started. First of all, arrange this all the element in the form of increasing order by 1, 2, 3, 4, 5 and 6 in this format. So first of all, A is lesser, then write this code. After A, D is lesser, so write D's code. After that, E is lesser, so write its code. After that, B is lesser, so write it code. After that, C is lesser, so write C's code. Now these codes are written here in the increasing order. Consider pair of the two lowest element, that is first A and D, written here, that is 0.1, 0.15, and this two element sum is the peak element of this two elements. So sum these two elements, that is 0.25. Now consider next two elements pair having two elements, that is E and B, that is 0.15 and 0.2. Now sum that two element as 0.35 and 0.4. It is the separate single pair. Now assign them their code A, D, E, B and C. Compare these two trees having 0.25 and 0.35. These two trees are less than 0.4, So to create the tree, we have to get the sum of these two trees here. We can write 0.1, 0.15. As it is, we can write upper side. The sum is 0.25. Now here 0.15, 0.2, and the sum is 0.35. As we return upper, it is a 0.35. Now sum to this element of 0.25 and 0.35 is 0.6. Remember, this is the 0.35, and 0.4, it is the separate element, that is C. Now compare these two elements, that is 0.6 and 0.4. Which is the greater? 0.6 is the greater, so must be in the right side. 0.4, it is lesser, so must be in the left side. Now to create the whole tree, write as it is, that is 0.1, 0.15, the sum is 0.25. Now the 0.15, 0.2, the sum is 0.35. Remember, it is 0.35. Now get the sum of this as 0.6. Now compare 0.6 and 0.4. Which is the greater? 0.6, so it must be in the right side, and 0.4 is in the left side. So write here 0.4 and get the sum of this as 1.0. Here, first of all, assign them the message character, that is A, D, E, and B and C. And to calculate the Huffman code for this message A, D, E, B and C, assign left subtree as 0 and right subtree as 1. So the characters are and codes are A, B, C and D. 100, 111, 0, 101 for E, 110. By this you can calculate the any Huffman code for the tree.